So here's a quick example of how to perform some elementary calculations with angular variables. The problem states, the rotor on a helicopter turns at an angular velocity of 3.20 times 10 to the 2 revolutions per minute. Part A asks to express this angular velocity in radians per second. First off, we express the angular velocity, which can be written as omega, which is equal to 3.20 times 10 to the 2 revolutions per minute. Next, we apply the conversion factors. 1 revolution equals 2 pi radians, and 60 seconds equals 1 minute. So we start out with our initial number, 3.20 times 10 to the 2 revolutions per minute. We multiply that by the 2 pi radians, and since we want our revolutions to cancel out, we put the 1 revolution as our denominator. The revolutions cancel out. Next, we multiply the other conversion factor. 1 minute equals 60 seconds, and we want the minutes as our numerator in order to cancel out the minutes from the denominator over here. And our final answer for part A is 33.5 radians per second. Part B asks, if the rotor has a radius of 2.00 meters, what arc length does the tip of the blade trace out in 3.00 times 10 to the 2 seconds? We're finding the arc length traced out by the tip of the blade. First up, we need to multiply the angular velocity by time to obtain the angular displacement. So for part B, we need to solve for delta theta, which equals the angular velocity times time, which equals 33.5 radians per second times 3.00 times 10 to the 2 seconds, which equals 1.01 times 10 to the 4 radians. Next, we multiply the angular displacement by the radius to get the arc length. That's delta S equals r, our radius, times delta theta, which is the angular displacement. That equals 2.00 meters times 1.01 times 10 to the 4th radians, our answer from before. When you multiply those two numbers, you get 2.02 times 10 to the 4th meters. Part C asks, the pilot opens the throttle and the angular velocity of the blade increases while rotating 26 times in 3.60 seconds. Calculate the average angular velocity during that time. To calculate the average angular velocity of the blade while the angular velocity increases, we apply the equation, noticing that delta theta equals 26 revolutions times 2 pi radians over revolutions, our conversion factor from the part A, which gets you 52 pi radians. Now we're solving for the angular velocity as it increases. That's omega, which equals delta theta, our new delta theta, divided by delta t, which is change in time, which equals 52 pi radians over 3.60 seconds. which equals 45 radians per second. So now we circle our final answers from all parts. And that's all to the problem. Thank you for watching and listening.